To achieve a consistent lighting situation between real and virtual environments is important for convincing augmented reality applications. The Virtual Showcase is a multi-user optical see-through display that is compatible to conventional showcases. Our latest prototype consists of up to 4 tilted CRT screens that are reflected by a pyramid-shaped mirror beam splitter. A combination of video projectors and cameras, called responsive light projectors, allows to receive information out of the virtual showcases inside and to illuminate the real objects on a per-pixel basis. They are used to capture reflectance information from diffuse real objects and to illuminate them under novel and consistent lighting conditions. Here is an example of an inconsistent lighting situation. While the real wooden plate is illuminated by a uniform white light radiating from the projector, the dragon is shaded by a virtual light source. Our new algorithm applies hardware-accelerated shadow mapping and shading techniques. Note that the shadows and the shading on the real and the virtual objects are now consistent. Here is another example of an inconsistently illuminated augmented scene. Note that with our algorithm, shadows can be cast from virtual objects onto real ones and vice versa. Using cube mapping and the captured reflectance information, real objects can be reflected by virtual ones. Last year, we introduced a new method that uses projected light for creating consistent occlusion effects within optical see-through environments, called occlusion shadows. A main drawback of this method is its limited support for multiple viewpoints. If the same real surface is simultaneously visible from multiple points of view, individual occlusion shadows that project onto the surface are also visible from different viewpoints at the same time. To avoid this problem, the captured reflectance information can be optically overlaid over the wrongly visible real shadow portions. Occlusion shadows that are created for other users are made invisible by partially covering them with a virtual representation of the real object. A next important step towards realism will be to visually enhance the virtual components while retaining interactive frame rates. This might allow blurring the boundaries between real and virtual even further.